In this video, I'm going to show you how you can build your own voice assistant speaker that runs local wake word. It takes less than 45 minutes. It requires no soldering and no programming. And it can be built for less than $50. And I promise, even if you think you're not technical enough, you're going to be able to do this. Plus, when you're done, you'll have your own local echo that responds to your voice commands. Hey Jarvis, where am I?
Are you having a laugh? You are in the Slacker Lab studio.
For now, I want to keep the voice services as local as possible, but my device does leverage the Nabu-Casa cloud for text-to-speech because it just sounds better than Piper. But how local your device is depends on your setup, and for you, Piper may be good enough. Or you could throw in some ChatGPT if you really want that new AI smell in your smart home. There is a Jarvis section in this video a bit later where I show some easy ways to get started with your own voice commands, so stick around for that. But whatever your goal, to do this project, you're going to need some supplies. Like I said, there'll be no programming required to follow along. We will be working from the command line though. But I have a guide that you can follow along that has all the commands you will need. It has numbered steps, and I have numbers for the commands, so you will know exactly where I'm at and what command you need when. The biggest prereq is this video assumes you already have Home Assistant set up and running. On top of that, you already have a local assist pipeline set up. Perhaps you've already played around with one of the Atom Echoes. In any case, if you don't already have a local assist pipeline set up, there's a link in the description that walks you through how to do that. I probably should have done a video on that, but I forgot I already had set that up. And this video does assume you know how to use things like SSH to get into a remote device. But I will give you all the commands you need to do that. There are multiple ways to build your own Echo, but I built this one using a Raspberry Pi Zero 2W, which I found on Amazon for about $20 a piece. You will pay a bit more if you need the power supply, or if you want the entire kit that comes with some added things like a little case. You can also get the Raspberry Pi Zeros with the header pins already installed, but that does add some cost. If you don't want to buy them with the pins already on and you don't want to deal with soldering, there are header pins that you can hammer in and they cost less than $10. Vilros makes a little jig for literally hammering them in, and it works really well. The jig also comes with a couple of the pins. You'll also need a ReSpeaker 2-mic Pi hat. I got these for around $10. There is a 4-mic hat, but this guide assumes that you're going to be using the 2-mic hat, and it does work pretty well. You'll also need an SD card. I got a 2-pack for around $14. 64 gigabytes is going to be more than enough for this. You're also going to want an external speaker. I think the ReSpeaker requires a 4-ohm speaker for this interface, and I tried 2 different ones. These smaller ones, I got a pack of 4 for $10. And these bigger ones, 2 of them, cost me $7. The bigger ones sound better, but they do require a bigger enclosure. All in, that means you can get all of the needed hardware for less than $50, and closer to $30 if you don't mind soldering or you find some deals. I'll put some affiliate links to all of this in the description in case you want to support Slacker Labs when you pick up this gear. Those links, of course, don't add anything to your cost, and using them means the world to me. Now, for the enclosure, I'll leave that up to you. I will include the links to 2 different ones I 3D printed. I like the larger one because that larger speaker does sound a lot better. The enclosure might be the toughest part since not everyone has a 3D printer. But if you have a local makerspace, you might be able to leverage that. If none of that works, I'll show you how you can use your Google Home as a speaker for your voice assistant. You'll also need software to SSH into your device. If you have a Mac, you should be good. Windows, you may be good as well, but you might also need to install something like Putty. I don't know, that's really not my thing. And by my thing, I mean Windows. Or Putty. If you haven't already pulled up the guide that goes along with this video, go grab that link. The guide has screenshots and step-by-step instructions, as well as the commands you're going to need to copy and paste a little bit later. As we go along, I'll refer to the steps in that guide to make sure you know exactly what I'm doing along the way. Okay, let's start in that guide at installing the OS. First, we need to flash the SD card with the Raspberry Pi OS. If you don't have the Raspberry Pi imaging software, you might want to grab that. Put the SD card in your computer. That's a really important step. Then in that Pi imaging software, you're going to choose the device. For this, Raspberry Pi 02W, and the 2W is important. For OS, you'll want to go to the other option at the bottom. Then choose Raspberry Pi OS Lite 64-bit. 64-bit is also important if you want local wake word, which I assume you do. Then choose the storage. After that, you'll be prompted to edit some settings. I would go ahead and do that. Set the host name to what you want to call this entity. I would set the username and password as well. If you use a different username than Pi, it will mean you need to edit some of the info you use later. I'll show you what happens if you forget, because I forgot. Spoiler alert. And the password you set here will be the password you need to use to get into your Raspberry Pi, so make it memorable. Set your wireless information, and I went ahead and set the locale settings as well. After that, click on the Services tab at the top and make sure that SSH is enabled and that Use Password Authentication is marked. Then save. Then you can confirm that you're ready to write all of this to that SD card. On my Mac, I need to give the software permission to write to the SD card, and then off it goes. When it's ready, we can click Continue, and then let's take this SD card over to our Raspberry Pi. Take that freshly flashed SD card and gently jam it into your Pi's slot. That's what Paul said. When you power it on using an adequate power supply,
Don't get cheap on me, Dodson.
you should get a green light. No green light means your SD card isn't detected or potentially not flashed. But once you're good, you can go ahead and put on that mic hat. And we're going to wait for all of this to boot up. Now that we have our OS installed and the hardware powered up, it's time to head to the Install Software section of the guide. We'll start at step 0. After you have the Raspberry Pi OS installed and you have powered on the 02W, you can start setting it up as a Wyoming Satellite. To do that, we're going to need to SSH over the network to the Pi 0. To do that, you'll need to use something like PuTTY, or if you're on the Mac, you can just use your command line like I'm going to use. To get access to our 0, we need to use the SSH command. In the guide, you can find the command at C0.1. We're going to copy that, paste it into our terminal, and hit enter. If you change the username during the OS customization step, then you'll need to change it in this command. If you didn't change it, the username may still be Pi, instead of has as it is in my command. Likewise, if you updated the host name during that OS customization step, you may need something other than Jarvis-master bedroom. But once you're successful, your screen should look like this. Now we need to set up the Wyoming Satellite software. And to do that, we're going to need to install some software. So in the guide, head to step 1, update the OS. And we're going to type or copy and paste the command c1.1, which is sudo space app-get space update. We'll hit enter, and when it's done, you should have a new prompt. Step 2, we need to install Git. We're going to use the command at C2.1. We'll copy all of that, paste it into our terminal or into our SSH client, and hit enter. It will run for a little bit, and when it's done, our screen should look like this. Step 3, we need to clone the Wyoming Satellite repository from GitHub. So we'll grab the command C3.1, which is a git clone command. We'll paste that into our terminal or SSH client and hit enter. This one will download some software, and we should see this when we're done. Step 4, we're going to install drivers for the 2-mic hat. This also includes the drivers for the 4-mic hat, but like I said earlier, this guide is focused on the 2-mic hat. Regardless though, we'll use the command C 4.1, which is a change directory command, to change into the directory we just created with the previous command. Once we're in the Wyoming Satellite directory, we'll need to grab the command C 4.2, which installs the ReSpeaker drivers. We'll copy that, paste it into our terminal, and this one may take a little bit of time. But when it's done, your screen should look like this. Step 5, we need to reboot our system now that we've installed all of this software. And that is what command C 5.1 does. So we will type or copy and paste that sudo reboot command into our terminal or SSH client and hit enter. And reboot will take a couple of minutes. After a couple of minutes, we can go on to step 6, which requires us to SSH back into our Raspberry Pi Zero. Command C 6.1 is that SSH command we used prior. So make sure it matches whatever you used back up in the earlier step. Step 7, we need to install the Wyoming Satellite dependencies. So we need to change the directory back into that Wyoming Satellite. So C 7.1, we copy and paste that change directory command, and when we hit enter, we can move to command C 7.2. We're going to copy all of that. We're going to copy all 8 lines of that command, paste it into our SSH client or terminal, and hit enter. And when it's successful, it should look like this. Step 8 is just a simple test to make sure that everything has gone according to our plan. Command C 8.1, we copy and paste that, which just runs a help command. And if we see output from the help command, then we know we're good. If you get an error or it says that the command was not found, I would start over at step 1 in the guide and go through each step again to see if something was missed. But if you are successful, you can move to step 9 in our guide, which is to make sure the ReSpeaker Hat is detected. And this assumes that you've already connected that ReSpeaker Hat to your Raspberry Pi, like we did during the hardware section when we booted up that Pi. Command C 9.1 in the guide simply gets a list of all the attached audio devices. So when we run that command, we should see output that looks like this, and we're looking for this right here. If you're using a different speaker, then you're going to see something different. Step 10, we're going to record some test audio. Again, this assumes that you saw the speaker that you have attached to your Pi in the previous step, but now we can grab the command C 10.1, which is going to record a 5-second test audio. We'll paste that command into our terminal, hit enter, and we should see that it's running. Now we need to say something. This is just a test of the speaker. And once we've recorded our audio, we can move to step 11, which is to test the playback. Command C 11.1 plays the test audio we just recorded. So we'll copy that command, paste it into our SSH client or our terminal, and when we hit enter,
this is just a test of the speaker.
We should hear the recorded sample play, and your terminal output should look like this. Step 12, make sure the Wyoming Satellite will run. So we're going to grab command C 12.1, we'll copy and paste all of the lines there into our terminal or SSH client. And if it's good, your screen will look like this. Now, we should also be able to flip over to Home Assistant, and under Integrations, you should now see a satellite show up as discovered, which means we're on the right track. Back in our terminal, we need to close this app, which is running live. And we'll do that by pressing Ctrl+C. That will give us our command prompt back. And now, we need to set up a service that will run anytime the Pi is started. Step 13, we're going to create that Wyoming service. So grab Command C 13.1, either type it, copy it, and paste it into your terminal, and you should have a window that looks like this. Now, we need to grab everything that is in C 13.2. We're going to copy all of that and paste it into this blank terminal window. We need to update some things in this text though. On the line that starts with exec start equals /home, you need to make sure that Pi is your username. And I'll show you what happens if you forget. I also wanted to update the name, which you'll see on that line, as my satellite. So in between these quotes, we need to change this to a new name, and I changed it to the name I wanted to use, Jarvis-Master Bedroom. You will also need to make sure that you update your working directory line and that the username referenced in that, which is Pi by default, is in sync with whatever name you set up during the OS customization stage. Once we've made the changes, we can hit Control X. It'll prompt us to save the modified buffer, and we'll type Y and then press Enter to complete the save. Step 14, we're going to enable the service. So grab Command C 14.1, copy or type it into your terminal or SSH client, and hit Enter. You should see a line that says a SIM link was created. Step 15 is to check to make sure that service is in fact running. So we're going to type or copy Command C 15.1 into our terminal or SSH client. And you will see the following if the service failed to start. And in my case, the problem was I forgot to change the username when I set up that service earlier. So I'm going to press Ctrl C to close this. Then I'm going to type or copy the command C 15.2, which brings back up that service that we had created. And as you can see, I did forget to change the username from Pi to Has on both the exec start line and the working directory line. So I'll make those updates, and after that, I'll hit Control X, type Y to save the buffer, and press Enter. Now we can restart the service after we've made our changes. To do that, we'll use the command at C 15.3. We'll put that in our terminal and hit Enter. And then, if we want to double check to make sure everything is good, grab the command at C 15.4, copy that, paste it into your terminal. Now you should see it running as it should. Step 16 is adding the Wyoming Satellite to Home Assistant. So we can head over to Home Assistant, jump into Integrations, and you should see your discovered satellite like we did before. Now we can click Configure, and then Submit. The device should have the name you set up in that service we created on the Pi. You can always change it later if it doesn't. We're going to choose the area it will be in my case the master bedroom, and click Finish. Now we can scroll down to the Wyoming integration. Click on the Services link. This will give you a list of your current Wyoming satellites, and you can click on the one you just added. In my case, that is the Jarvis-Master Bedroom. Here we can set the Assist Preferred Pipeline. For me, it's Jarvis. And with that, we now have a Wyoming satellite. Now we can head back over to our terminal window and make it a little bit better. Step 16, we're going to add some audio enhancements. If you want, you can set the audio gain and the noise suppression, and for more details on these values, check out the original guide linked at the top of my guide. We need to open our Wyoming service config, the one we just edited. So we're going to copy or type the command at C 16.1, which opens that file back up. Then we're going to move our cursor down to the exec start line, and then all the way to the far right or the end of that line. Here we need to type or copy and paste the following to the end of that line. Here we need to type or copy the text at C 16.2, which is -- Mike -auto-gain 5, along with the noise suppression part. We'll paste that at the end of the line. Then we'll save our changes by hitting Ctrl-X, typing Y, and pressing Enter. Then we need to restart our Wyoming service by using the command at C16.3. And once we've restarted it, we can move on to step 17. Now, before we can install the local wake word software, we need to make sure that we have all of the dependencies in place. So we're going to type or copy the command at C17.1, which is a system update command. When that's done, we can run the command at C17.2, which installs the dependencies we need. You may be prompted to continue after hitting Enter, so type Y and hit Enter again. And when it's done, it should give you a new prompt. Next, in step 18, we need to clone the open wake word software. And we're going to need to make sure we're in our home directory before we do this. So if you're still in that Wyoming Satellite directory, you need to grab the command at C18.1, which is a change directory command, CD. We're going to paste that into our terminal and hit Enter. Now that we're in our home directory, we can grab the command at C18.2, which is a git clone command. We'll copy that, paste it into our terminal, and hit Enter. And when it's done, your screen should look like this. Step 19 is running the setup for the local wake word, so we'll have to change our directory again using the command at C19.1, which puts us in the Wyoming-open wake word directory. Once that's done, we can grab the command at C19.2, which executes the setup. And once that's done, our screen should look like this. Now, step 20, we need to create the local wake word service, like we did for the Wyoming service. So we'll grab the command at C20.1, which opens a new Wyoming-open wake word.service file. Our screen should look like this. Now, we need to grab all of the text that's at C20.2. We're going to copy everything from unit down to .target, and we're going to paste that into our terminal or SSH client. Be sure you update the usernames in this file as well at the exec start line and the working directory line, replacing pi in that line with whatever you created as your username. Once you have that done, you can hit Ctrl+X, type Y, press Enter, which saves the file. And we can move on to step 21, which is add local wake word to the Wyoming service. So grab the command at C21.1 and paste that into your terminal. When you hit Enter, it should open that Wyoming Satellite service, which should look familiar by now. Under the unit section, we need to add a line. So grab the text at C21.2, and we're going to paste it at the end of that unit section, and it should look like this. Then on the line that starts with exec start, we're going to need to add something to the end of that line. So grab the text at C21.3, and we're going to copy that and paste it to the end of that exec start line. So it looks like this. In my case, I updated the wake word name from OK Nabu to Hey Jarvis. Then, after we've made our updates, we need to save the changes. Ctrl+X, type Y, and then hit Enter. And we should be back on the command line. Now, we need to reload our services since we've made changes. So grab the command at 21.4, paste that into your terminal or SSH client, and hit Enter. Then grab the command at C21.5, which is going to restart that Wyoming Satellite service. Once we've pasted that in and hit Enter, after you've done that, we can check to make sure that everything is good. And we'll grab the command at C21.6, paste that in, and on the screen, we should see that our services are both active, running, and green. Hit Ctrl+C, and now we can move on to step 22, which is test your wake word. The easiest way to see if your wake word is working is to jump into Home Assistant. As you can see, my device here is still up. and I'm going to watch this assist in progress sensor. If I say the trigger word, "Hey Jarvis," you'll see the assist in progress sensor go active, which means everything is working as it should. Now, step 23, we're going to enable the LEDs, which aren't necessary, but they do give some visual feedback. Again, this assumes you have the 2-mic hat because the setup would be slightly different for a different speaker interface. Before we can do anything though, we need to change our directory back to our home directory. So we're going to grab the command at C23.1. We'll paste that into our terminal and hit enter. And now we need to move back into the Wyoming Satellite directory, specifically the examples directory. And we'll use the command at C23.2, paste that into our terminal and hit enter. Then we can install the packages needed for the LEDs using the command at C23.3. We'll grab all 4 lines and we'll paste that into our terminal or our SSH client and hit enter. And when it's done, your screen should look like this. To make sure that you have all the needed libraries to run the command, grab the command at C23.4, which is a sudo apt-get install command. Paste that into your terminal or SSH client and hit enter. If you didn't get any errors, then you should be good. And we can move on to our test command. So grab the command at C23.5, which just calls the help service. When we hit enter, we should see some help dialog. Step 24, we need to create an LED service, like the 2 previous services. So grab the command at C24.1, paste that into your terminal or SSH client, and you should get that blank terminal window to create a new file. We'll grab all of the text at C24.2, and we'll paste that into our terminal window. Be sure that you update the usernames again on the exec start line and the working directory, making sure that you change pi to whatever username you created. When that's done, you can hit Ctrl+X, type Y, and press enter to save the file. Now, we need to go back and edit the Wyoming service to make sure that it includes these LED service. So grab the command at C24.3, paste that into your SSH client or terminal window, and hit enter. And we'll grab the text at C24.4, which is a requires line. We're going to copy that and we're going to paste it at the end of our unit section. And when we're done, our file should look like this. Now, grab the text at C24.5. We need to add this to the end of that exec start line like we've done before. So copy that text, move down to the exec start line, navigate all the way to the far right to the end of that line, make sure you add a space, and then paste in the --event-URI. When you're done, it should look like this. Now, we can save our changes by hitting Ctrl+X, type Y, press enter. Now, we need to reload the services again, so we're going to grab the command at C24.6, paste that in, hit enter, and it should reload the services. Grab the command at C24.7 to restart the Wyoming Satellite. We'll paste that into our terminal and hit enter. And if you want to do one final check, grab the command at C24.8, paste that into your terminal or SSH client, hit enter. And everything you see should be active, running, and green. Now we can hit Ctrl+C to exit this, and on the prompt, type exit and press enter. And now we've configured our Pi 0 with local wake word and LEDs. Now that we got all of our software set up, we can button all of this up into our enclosure. I screwed this into the enclosure using some KM flat head screws. These are M2 screws that are about 5 millimeters in length. I secured the Pi 0 to the bottom of the enclosure. Then I attached the ReSpeaker to the headers, and then attached the speaker to the enclosure using those same M2 screws. I've been playing around with some speaker fabric to see if I can make this look good. And so far, I haven't quite figured out how I'm going to attach this so that it looks good and so that I can remove this top when I need to. But when I do finally solve that, I'll post an update. Now, of course, here comes the fun part. I have not built a lot of functionality around these devices yet, and a lot of people are going to want to jump right into ChatGPT. Again, I want to keep things as local as possible, but I want to show you how you can start using this setup today. Now, let's say you don't want to go through all of this trouble, or perhaps you have one of these echo atoms laying around that you've already flashed and can respond to your wake word. But this echo atom doesn't really have a speaker worth anything, and connecting a real speaker isn't plug and play. In that case, I would start with an automation. For our trigger, we're going to use sentence. And for this example, I'm going to set this sentence to, what time is it? Then we'll skip down to the actions. And for the first action, we're going to use this set response action. And we're going to leave it blank. This means we won't get an audible response back after we've set our sentence and prior to getting the actual response. Then the next action I'm going to use is the cloud say for Nabu Casa. I will set the entity to the Google Home speaker here in my studio. And for message, I will paste in this template right here, which will get the current time. Now, with this automation, we can trigger our voice assistant with that phrase we've set up, and the response will come back on a Google Home. Hey Jarvis, what time is it?
It is 9:01 a.m.
Not a perfect solution, but it does get a working voice assistant that doesn't require us to set up a speaker and will work with that Atom Echo. And the automation route does make it really easy to get going. You just have to define your triggered phrase for your specific commands, like, hey Jarvis, give me a haiku.
You might like in the light, in the morning light. You sleep despite my meow. I stand on your face.
But you could also build your own intents really easy. These, of course, can get super complex, but let's start out simple. For this, you're going to need to jump into your YAML configuration files.
It was my understanding that there would be no math.
You can add this to your configuration.yaml file, but I had a jarvis.yaml file in my packages directory where I was already putting Jarvis-related things. In either your configuration.yaml file or that file in your packages directory, add a conversation colon section like this. Under that, we'll indent, and we're going to add intents colon. Under that, we can define each of our new intents. Think of these like names of functions or sentence templates. This one I named Where Am I, followed by a colon. Then under that, each line is preceded by a dash, then in quotes, a verbal phrase I would use to refer to the Where Am I function. I have 3 sentences for this one. And for the next one, Are you awake? I have 2. These sentence templates can get way more complex, with placeholders, and can even extend the built-in intents that the Home Assistant team has already created. But again, we're just going to keep it simple. Since these are custom, then we need to include a intent_script section, like this. This is going to define the actions that happen when our voice assistant hears one of those sentences we've defined in the conversation section. Under that intent_script heading, we'll define each of these intents. Where am I colon, for example. Then for any speech to be said back in response, you'll add a speech colon, and then under that, define your text that you want to be converted into speech. For Where Am I have a template that gets the current room based on where the last triggered Jarvis voice assistant entity is, which should be the one that I used. Then it simply provides a random response. If you wanted to include actions, you could add an action section here as well, and then add in service calls to turn on lights or anything else. Once we have all of this defined in our config, we can restart or reload our conversation and intent script config. And now, anytime we trigger our voice assistant and say one of those phrases, we will get our response. Hey Jarvis, Are you awake?
For you, always.
Now, we're just scratching the surface here. There is a lot we can do with this, and very quickly you can add a lot of the functionality from the Echo or the Google Home and never have to touch a cloud service. But unless you want to shortcut it by using something like ChatGPT to help fill in some of the info, it will take time to get your voice assistant up and running. That said, the Home Assistant team is also adding a lot of functionality to these built-in intents, so I expect that the capabilities are going to grow really quickly. I'll include links to my automations and conversations and intent scripts that I've showed off today to help you get started. I'm really impressed with how well the Pi Zero 2 and the ReSpeaker work, even from across the room. It's not going to work 100% of the time, but neither does the Google or the Google Home. And it does seem to randomly trigger on noises that aren't words and incomplete wake word phrases, where I was already putting Jarvis related.
I couldn't understand that.
But I've already built 3 of these and will be building 3 more to be my main voice assistant, to replace the Echo, which we hardly use today, but I think this is going to be more fun. And no doubt, I will also buy the Home Assistant hardware version when it finally comes out. Let me know what you've tried or what you're waiting for before you go all in on an Echo or Google Home replacement. And if you're still here, thanks for sticking around. This has been a long one. Let me know if you think I should sell the speaker enclosures. I can't promise anything, but I am considering it for those that can't print their own. Anyway, we probably should get back to life, right? Or we could just sit here and stare at each other. Yeah, okay, that's awkward.